Experiment 8 is about gas laws. And in this experiment 8, the title of the experiment is Boyle's Law and Measuring the Gas Constant R. Objectives of this experiment is to study the relation between the pressure of a gas and its volume, okay? Or in short, Boyle's Law. And in addition to that, to measure the gas constant using an experimental technique. In this experiment, we're going to deal with gas laws. So, as discussed in the lecture, okay, we said that gas can be at least described by 4 experimental variables. Okay, you have the moles, the temperature, the pressure, and the volume. Okay, now these variables were first studied by different scientists. For instance, one of the first natural laws that's being put forward was by Robert Boyle, wherein he studied the compressibility of gases in 1661, and he observed that the volume of a fixed amount of gas at a given temperature is inversely proportional to pressure. Okay, so this is Boyle's law, wherein pressure is inversely proportional to volume, or the other way around. Okay, and you're going to have an application or the description of the Boyle's law in one of the experiment today. Now, in 1787, Jacques Charles found that the volume of a fixed quantity of gas at a constant pressure increases with an increase in temperature. So here, Charles said that volume is directly proportional to temperature. Okay? And then Amadeo Avogadro further states that the volume of a gas at a given temperature and pressure is also proportional to the quantity of gas or to the number of moles. Okay? So we can describe it in terms of volume is directly proportional to the number of moles. So if you're going to look at this, all of them in one way or another are variable, or we could say uh, experimental variable of a gas. And when you combine them, you will have the so-called ideal gas law. And the one that combined the ideal gas law, if you're going to combine them, is the R value. Okay, so R is just equals to PB over NT. And that's what you're going to obtain in this experiment. In the first part of the experiment, we're going to do the thermal decomposition of potassium chlorate. Okay, so as you could see here, you have an amount of a potassium chlorate that you're going to heat in an enclosed container, okay, producing KCl and oxygen. So oxygen will be collected in a way that the produced gas will displace a volume of water. Okay, so from this experiment we'll be able to get the volume, the temperature, and the pressure, and lastly the moles of the oxygen gas. Okay, and having all these variables, okay, we are going to determine the R value. So if we're going to remember, PB equals to nRT, that's the ideal gas equation. So to get R is just equals to pressure times volume over moles times temperature. Now in the second part of the experiment, what we're going to do is we look at the relationship between pressure and volume. So what happened, okay, in a setup wherein we decrease the volume or we increase the pressure. Okay, so we could say this is evidence on how the Boyle's law works. For the thermal decomposition setup, so we're going to weigh certain amount of KClO3 and we're going to place it in a test tube. And what we're going to do, we're going to have a setup like this. So we have a Florence flask that contains water. Okay? Now, we have to make sure that it's sealed properly. Okay? Because that's the only way we can determine how much volume of oxygen was produced, because what will happen, the oxygen that will produce here, okay, it's going to displace the water in the Florence flask, and the amount of water or the volume of water that was displaced, that equals to the volume of the water. So you have to make sure that there's no leaks, and when the experiment starts, you make sure that the pinch clamp is open here, or else there could be a build up of the oxygen gas. So that's the principle that we have here. So from the volume of the water that collected, we'll be able to get the volume of the oxygen. Now we're going to record the temperature that we have, and then the corresponding pressure at the given temperature, and the mole of the oxygen can be indirectly calculated from the mole of the KClO3. For the second part of the experiment, we had a setup like this, wherein we have a syringe and a plunger. We're going to put it in a gas pressure sensor. So what we're going to do, we start at a certain volume and determine the corresponding pressure that it has. And as time goes by, we're going to apply pressure to get to the desired volume that we have. So usually what will happen, the volume will decrease. And as you're going to observe, once you want to decrease the volume, you need to apply a lot of pressure to get that thing. Now, the corresponding volume that we get will result to a corresponding pressure recorded by the sensor. Here is the raw data that you obtained from the experiment. And you have this in your lab report already. Okay? So you have here the corresponding moles or the mass of the KClO3. It's 1.394. And then you have the water volume of water displaced 191 ml. So you just convert it to liter, okay, by the equivalent of ml to 1 liter. And then you have the temperature of water, which is 23, which you need to convert to absolute scale. Okay, and atmospheric pressure is given as 763. And the vapor pressure of water at the temperature of 23 degrees Celsius is 21. So to get the pressure of the oxygen, you're going to subtract 21 with 763. So you're going to get around what, 741 or 42 millimeter mercury. And then from that, you're going to convert your millimeter mercury to atmosphere. Now, the main thing that you're going to do is calculate the value of R. So how are you going to get the stuff that you need? Okay, so the volume is already given. You're fine with the volume, right? So we say R is equals to PB over NT. So volume is already given. So that's the one that you're going to what we could get. Now, for the pressure, it's just 763 minus 21, get the millimeter mercury, and then you're going to convert it to atmosphere. Okay, so that means it's there. Temperature is the one that you have here. All you need to do is get it in terms of Kelvin. The one that you need to calculate is the moles of the oxygen. So how are you going to do it? So you have here the mass of KClO3. So all you need to do is convert this to the mole KClO3. So once you have the moles of KClO3, you're going to convert it to the moles of the oxygen. Now you have to look at the equivalent. Okay, so usually 1 mole of oxygen is equals to what? 3 over 2 moles of KClO3. Where did I get this relationship? It's based on the what we call stoichiometric ratio. For the Boyle's law data, this is what you're going to use. It's already in your lab report form. So what you're going to do is you're going to plot them. So this data is available in an Excel file in the folder. So the first plot that you're going to do is you're going to plot pressure versus the volume. And you might have a plot like this. Okay? So the next thing that you're going to do is get the reciprocal of volume. So you can do it in the Excel. Okay? And what you're going to have there is 1 over volume and then the pressure, and your plot would look like this. So the step that you need to submit here, you completed the data, or you process the data there to give you the R value. So you need to report the R value that you get. Okay? And then you need to have these plots included in your lab report and answers to the different question. Okay?